All right, it is noon Eastern time, so let's get started. Welcome to the second day of peer review presentations for Geog 596A. I'm Jim Detweiler, the faculty lead for the Geospatial Programming Certificate. For those of you who don't know me, I'll be the MC for today. We have 4 presentations. First, a few reminders. Presenters, you'll have 25 minutes to give your talk, followed by 5 minutes of questions. Audience members, if you have a question for a presenter, please enter it into the chat box. You might consider typing your question into a separate text editor, then copying and pasting it into the chat box when the presenter wraps up, so you're not distracting them during their talk. Presenters, please read the question out loud so that anybody watching the recording will know what you're responding to. And 596A students, we're expecting you to provide each speaker with constructive feedback. Others who are attending are invited to do so also. And I've posted a link to the peer review form in the chat box. So first up, we have Madison Russell. Madison, are you ready to go?
Yep.
All right.
Hold on, let me share my screen.
Okay.
Can everybody see it?
Looks good.
Okay,
Take
great.
it away.
All right. So hi, everyone. My name is Madison Russell. I am in my last year of the program, so we'll be done in May. Very excited about that. And I'm doing my capstone project on education disparities in Fulton County, Georgia. So today's agenda, we're going to go over the main question and why I care about it, the reason behind I chose this project. We're going to go into the background of racial inequity in the U.S. and educational disparities in the U.S., focus on Atlanta, background of Fulton County with its history and race, and the reason it's shaped the way it is. And then we're going to review the equity report. We're going to go over data, methods, and variables for the study, and expected outcome of study and timeline. So my study question is, what do educational disparities geographically look like in Fulton County? I chose this project mainly because I grew up in Fulton County. My entire K through 12 education was in North Fulton County, right? I don't know if you can see my mouse, but right over here in Johns Creek. That's where I grew up. I went to Abbott Hill Elementary School, Taylor Road Middle School, and Chattahoochee High School, as you can see it right here. And so I experienced a lot of these, educational disparities firsthand. Not that my education was the one, that was lacking, or thereof for South Fulton. So the way that South Fulton works, and we'll get more into it later on, is that North Fulton is very much separated from South Fulton County, even though they are technically all Fulton County. It has a really funny shape, the county. It's kind of how I describe it, like a plant. So the bottom is the bulb, and then Georgia 400 is the highway that goes up this way, and then it's the leaf at the top. So all of up here is North Fulton County, and then once you get past here, 7585 and south, that's South Fulton County. And you can really tell that you're in South Fulton County because the infrastructure is not necessarily there. It's not as prominent as in North Fulton County. And we'll go into reasons for that later on. But personally, when I was in middle school, we had end of course exams. And a lot of us in our classes, we never really studied for them because we knew it was easy. It was, it was fine. We get 80s, even if you didn't get an 80 and you ended up failing, it never mattered. Because in North Fulton, we all had a much higher outcome from those exams than a lot of the kids in South Fulton. So what the county as a whole would do, they would curve all of the exams for the entire county. So even if a student in Johns Creek got a 75 on their end of course exams, they'd end up getting an 85, 95 anyway because of the curve. And they did this so that the kids in South Fulton County who would get 40s, 50s, 60s would be able to consider passing. And I it personally affected me. So that's one of the reasons I chose this project. The other reason is we had kids that would have to hardship from South Fulton, and they would take a van every morning up to our school in Johns Creek. It was with traffic, with rush hour, 45-minute drive minimum each way. And so, but they came all the way up to our school so they could get a better education. And because we had programs that their school didn't offer. So we're going to get into the history of race in Atlanta. So as many of you are probably aware, Atlanta has a very deep-rooted history in racial segregation, starting all the way back with slavery and Jim Crow laws. You can still see a lot of the impacts of those today when you drive through Atlanta. The civil rights movement was largely impacted Atlanta, with Martin Luther King leading the charge to disrupt this racial segregation in the South. And he was actually born here. So a lot of the movement of the civil rights movement was really important to everyone here. And we have a lot of monuments for Martin Luther King. And back before, even before the civil rights movement, when slavery was going on in the Civil War, and then after with the Jim Crow laws, the South has always been, and especially Atlanta, very much a center of racial segregation and inequity. And as I mentioned before, as you drive further and further south in Atlanta, you can really tell that the areas that are more predominantly racially segregated are lacking in infrastructure and have lower. If you look at, demographics, there's a lower income in those areas, and the household, the average household income is lower, not to mention just single household income. The unemployment rate is lower, and education and graduation rates is lower as well. And that's something that we really need to focus on in Fulton County, so that students really are getting an equal education across the board, because it's really not happening at the moment. So I've mentioned some of these in Fulton County. The causes of this racial and education disparity that we see are taxes. And that's because North Fulton, a lot of the areas in North Fulton, which is a lot of this lighter area, they have a higher average household income, with the average income being middle to upper middle to higher class. And which means they're also majority in a higher tax bracket, which means they have more money going to the schools and extra money, on the side to donate. So a lot of parents and business owners donate a lot of money to public and private schools in North Fulton County because they have it to donate. Specifically, for sports programs or arts programs, a lot of them get donations privately from families that have the money to donate. Versus if you're looking in South Fulton County, where the unemployment rate is a little lower and the average income is lower to middle class, they don't have as much money to just spend and donate to, their schools. And since they're in a lower tax bracket, there's less money going to their schools as well. So while the whole county is one entire county, it's still very much separated with taxes. And so the other reason is, computer and internet access is lower in South Fulton than it is in North Fulton. The continuous public transportation, North Fulton has MARTA buses. I don't know if any of you have heard of MARTA, but it is the Metropolitan Atlanta Transportation Association, I believe. And so we have a train. It's essentially just a regular, high-speed rail train, and it'll take you, but it only goes north, south, east, and west in Atlanta. It only goes as far north as exit 4 or 5 off of Georgia 400, which is a highway. So it stops right here in Sandy Springs. It doesn't go all the way up into North Fulton, which means a lot of the people in South Fulton who otherwise would have been able to maybe look for jobs in North Fulton County or attend schools in North Fulton County don't have easy access to get there. And that's because honestly, a lot of the residents in Fulton County, in North Fulton County, have prevented any kind of legislation from being enacted to expand MARTA, because they don't want to expand it into their area, because they don't want a lot of people, namely, people experiencing homelessness, people unemployed, and all of that, and crime rates and everything. They don't want all of that being brought into North Fulton. So they've really prevented it, which is not the best. The other reason is school zoning decisions. A lot of the school zones that I'm going to look at for in Fulton County are very weirdly shaped and cut out sections of neighborhoods that are of minorities, and of lower incomes. And so I'm going to really be looking at, why they, what that does to the education in the area and how that impacts the students. And then the effects is, the education-based hardships that I mentioned before. We had, in my high school alone, we had about 25 kids that got bused from sometimes as far south as down here, all the way past the airport, all the way up to North Fulton, which is easily an hour and a half drive in rush hour. And I think that was the furthest they came from, to come to our school to get a better education, because the school that they were zoned for was not going to give them the quality of education that their parents thought they deserved and that they do deserve. And so we had, all of these kids were in my classes. They were all very smart, very intelligent, and they took part in after school activities, but they weren't able to participate in as many school activities and programs as they would have been able to had they had them near, close to their house, because they did have an hour and a half drive home. They couldn't stay until 4 p.m. They had to leave right after school, most times. So the impact, from not having the income in those areas, and the schools getting money from those areas, is that the school programs, there's not, test prep available. A lot of students in North Fulton in the high schools their parents pay for test prep, ACT, SAT, college preparatory classes, all of those things. South Fulton student kids don't necessarily get that or have access to that. Most of them don't, as well as tutoring. In North Fulton County, if you were not doing well in a class, you could go to any tutor within 5 minutes of your house, and it was expensive, but your parents had the money to pay for it, or the school helps you pay for it. In South Fulton, that's not the case. A lot of times students will struggle on their own to pass a class. The next is advanced classes. We had a lot of AP, AB, dual enrollment classes. We had magnet schools up in North Fulton, and there's magnet schools in South Fulton as well, but there's less of them. And they have a decreased access to AP and AB classes, which means when they go to apply to colleges, they might not have the same level of difficulty of classes that students in North Fulton would have. So just to give you a visual, on the left here, this is Fulton County. They're both images of Fulton County, but on the left is the percentage of the population that is of color. And on the right is the percentage of population that is white. And it's a very, very distinctive line, and it's very easy to see those differences in the race just within one county alone. And one of the other things I'm going to be studying is why Fulton County is shaped the way it is. It's the only county in Georgia that's shaped this way. And it's very interesting because a lot of, as I mentioned, the taxes from North Fulton, from the higher income tax brackets, pay for a lot of the infrastructure in not only their area, but also Atlanta, within downtown Atlanta and South Fulton as well. So to do this, the method I'm going to be using is a social equity analysis from Esri. And the solution itself is to analyze community conditions and actions understand community characteristics, evaluate equity at a community level, and measure progress over time. So one great thing, one of the great things about Esri is that, and working at Esri, is that I have access to, and so do a lot of people, have access to publicly available data sets, specifically the ones that I'm about to mention, but they cover the span of the entire United States, and you're able to extract data from them specifically for the county or areas you're looking at based off of census tract data. So I'm going to show you what variables I'm going to be looking at specifically. So in the ACS educational attainment variables data set, I'm going to be looking at income and race. And all of these are publicly available data sets. So anyone can download them to ArcGIS Pro. You can open them on ArcGIS Online. You can maneuver them however you'd like. You can manipulate them in any way and filter anything, any result you're looking for. So the social equity analysis takes several data sets, and you can actually decide which variables from each data set you want to use for your analysis. So ACS educational attainment variables, I'm looking at race and income. The ACS internet access by education variables, I'm looking at internet access and computer access at home, specifically at home for students. The Georgia Early Education Alliance for ready students for the 2020 data set, I am looking at the percent of at-risk youth and the percent of children below the poverty line. And the high school's post-high school progress graduation 2018, I'm going to be looking at graduation rates. So all of those together will give a good picture of how the education differs between North Fulton and South Fulton County. My guess is that it will show very similar to what the income and race maps look like, where there is a very distinctive line. And that's something that Fulton County really needs to focus on in the next, 5, 10, 15, 20 years to bridge that divide, so that all of the students in Fulton County have equal access to, the best education available to them. North Fulton County, for when I graduated from high school, 5 of the top 10 high schools in the state were in North Fulton County. How is that? It's baffling to me that can happen while South Fulton County kids are struggling to graduate, period. We're only 20 miles away from each other. So my timeline for this project, weeks 1 and 2 will be spent learning the workflows in the social equity index tool and practicing with those. Weeks 3 and 4, I'm going to be identifying and using the proper data to input into the solution, and the index will be created. So that's when I'm actually going to be creating this, using the solution to create the index and the analysis. And week 5 and 6 is going to be spent analyzing the results of the index and analysis and creating the final story map for the presentation. Week 7 and 8 will be used to write the final report, including drafting, editing, and final production. And weeks 9 and 10 will be spent practicing the final presentation to present at a conference. So my advisor and I are working on identifying which conference I will be presenting, and then practicing for weeks 9 and 10. So that is going to be my capstone project. I hope you guys enjoyed. This is me. And this is when I was in Ireland 3 years ago in 2019. I did a solo trip to Ireland for 3 weeks by myself. So yeah, hope you all enjoyed, and please feedback, questions. I'd love to hear it all. Thanks.
Okay, thanks, Madison. Let's open it up to questions then.
Hey, Madison, how are you?
Good, how are you?
I'm good. Hey, I just had a question, not so much about the analysis, but more so about just the role of, a cartographer and some data that you present. Oftentimes I find that we present results, but they are met with some resistance in terms of putting those results out to the public. Where do you feel about the stewardship of this type of information, and really ultimately, think about crime data. A lot of jurisdictions don't want to put crime data out there because they wouldn't want to deter someone moving to communities or to make some assumptions there. As a cartographer and as a demographer, like where do you feel on that topic?
So as far as that goes, I think specifically with crime data in Atlanta, most of it is pretty public. And I think if a municipality, say, Fulton County or any other county or city, doesn't want their demographics known of, what, whether it's their crime rates or what the education, looks like in one area versus another, it's very much, I think, along the lines of what's currently going on with and salary information, and having that that clarity, the upfrontness, and I think that's important for counties as well. If you don't want to hide something, then make it so there's nothing to hide. Fix it. Don't just cover it up, because people will find a way, especially in today's day of technology and social media. Everyone finds out eventually. Don't try and hide behind a curtain. Just admit that there's a problem and let's work towards fixing it.
Fair enough. Thank you. I appreciate the answer.
Mm-hmm. Okay, so David said, "Hi Madison, I enjoyed hearing about your project, especially since Fulton County is so much in the news lately. I wonder, have you discovered any comparable studies of educational equity in Fulton County that might inform your project?" There are a few. Well, there's specifically one study within that I found. Within Fulton County that I found. But it's not as much Fulton County itself. It's the Atlanta Public Schools has an equity report that I've been reading and looking at, and kind of understanding how they looked at what the variables they wanted to use for their study were, and how they went about that study. And it's about a 90-page report, so I'm about halfway through it. But it's very informative. Atlanta Public Schools is very much a lot of downtown Atlanta. Not as much South Fulton. So it's almost right in the middle of Fulton County is where Atlanta Public Schools is. So their equity report is, very informational. Other than that, there's not a ton of equity reports, at least in Georgia, that I've seen. And I know it's going to be different. The outcome would be different in every area. If you're looking at, somewhere in the north, somewhere up north, so let's say Chicago, well, not Chicago, but, somewhere that's doesn't have as deep-seated of an issue with race. I think the outcome would be different in every area versus, if you're looking in California versus Atlanta, it would be the same. So the data sets and the reports that I've been looking at really inform more Georgia areas. Thanks. Any other questions?
Hey, Madison. I just want to ask the question. I think that usually, I mean, this is it's a really, really big problem, right? And there's a lot of ways to potentially approach it, right? Especially using geography and GIS. But I just wanted to ask, like, in your opinion, what do you feel is going to be maybe the most difficult part of this project, this analysis that you're doing?
So the most difficult part that I've actually already run into the most difficult part, and that was really deciding what variables to use and which data sets to use, because unfortunately, and I guess fortunately at the same time, Fulton County is really trying to lean away from standardized testing. Specifically for, elementary school, middle school, and high school, standardized tests aren't as much, there anymore. So while standardized testing is not the best for students themselves, because everyone learns different, you don't try and teach a fish how to ride a bike because it's just not going to be their forte. But but it did give very good data on where students stood in different areas, different schools, and it was a very easily comparable data set. But Fulton County hasn't had an updated data set for the core curriculum and standardized testing since 2015. So it's been 8 years. So finding data sets and variables that I could use that were more recent, a lot of them, the most recent ones were 2020. So even then, it's still been 3 years. Who can say this study is going to look at how schools really were before COVID, because that's a whole other monster. Is if the data sets were available for 2022, 2021, I'm sure the information not only would be skewed for race, but also would probably be a lot more exaggerated than it's already going to be, just because of all of the at-home schooling that happened and the remote and virtual learning.
Awesome. Well, thank you for the answer and good luck.
Thanks, Reed. Any other questions? Any? Hello?
Yep, I'm here.
Oh, okay.
We can still hear you. Any
Yep.
last questions for Madison? All right, well, thank you for your presentation and best of luck on completing your work and finding a good venue to make your presentation.
Thank you.
And so that will take us to our next presenter, Brooke Aubry. Brooke, are you ready?
Yep, I am ready. Let me share my screen. All right, can it be seen and is my voice okay?
Yep, looks good. Sounds good.
Awesome, sounds good. Hello everyone, my name is Brooke Aubry and this is my 596A capstone pre-proposal on calculating change in building infrastructure due to Hurricane Michael using LiDAR. I'll first introduce the reasoning behind this project and the background, as well as other projects done by researchers on the same topic. And then goals and objectives will be stated with a look at the imagery downloaded. And the data sets I'll be using will be explained next, plus the pre-processing and methodology sections. And then the last 4 slides will contain the timeline, presentation values, and anticipated results. So disasters affect numerous places around the world, and having the right kind of data can make a difference in response and recovery time after natural or man-made disasters. One of these kinds of data is light detection and ranging, or LiDAR. LiDAR is a remote sensing instrument used to collect point data by generating pulses of laser light and detecting the reflection from targets on the ground. These pulses contain high-resolution 3D geographic coordinates, which then can be used to create 3D models of the ground surface, as well as above-ground features such as infrastructure and vegetation. These different features have various shapes and sizes, which will reflect light back at different speeds and be used to create those 3D models. This kind of data and model is helpful for researchers and those using raster imagery because it can be sometimes difficult to tell what an object is or even the dimensions of it just using aerial photography. One of the industries that LiDAR can be used in is response and recovery of disasters. 2 of the most important things when using LiDAR in natural or man-made disasters is if it's available fast enough, allows first responders to find the most important location for emergency response, or second, can identify areas of damage that need to be addressed in the cleanup efforts. By having a base LiDAR layer collected of an area prone to disasters before a disaster strikes, it can be possible to quickly identify the change between the 2 data sets and mark areas that have been destroyed or altered. Data gathered with LiDAR can be used for a number of natural disasters, including floods, hurricanes, tornadoes, and earthquakes. This data allows us to map flood inundation, topographic changes, infrastructure repairs, calculate storm surge, among others. LiDAR is a relatively new technology and is just starting to become more prevalent in today's data collection. There are several advantages to using LiDAR versus other types of data. First, LiDAR's ability to see beneath the tree canopy is a key asset. Because of LiDAR's use of direct range measurements, beams can record beneath foliage to capture bare earth products. Second is that the data can be collected day or night because it does not rely on the sun to illuminate the ground, and it can also pierce through clouds. Third, LiDAR has elevation data in itself, so height of objects can be determined, such as the buildings or trees. And lastly, it can also be used as soon as the data is downloaded from the sensor and can be combined with raster imagery to use as a guide. So for my capstone proposal, this research project will be on using LiDAR data in a change analysis between data collected before and after Hurricane Michael in northern Florida. LiDAR was collected in northern Florida in 2017 by the Northwest Florida Water Management District. And then Hurricane Michael occurred in October 2018, and LiDAR was collected right after by the U.S. Army Corps of Engineers. In this change analysis, the data and elevation changes between the 2017 and 2018 LiDAR point clouds can indicate areas that are damaged, such as fallen trees, destroyed houses, or objects blocking the roads. This analysis will be able to help show why the collection of LiDAR is important to facing response and recovery. The images in the slide are part of the raster imagery that I have of places hit by Hurricane Michael. You can see damages done to buildings, trees fallen, and obstacles across the roadways. For disaster management, the early collection method, and currently still used more than LiDAR, is driving around in a car or flying small aircraft above the disaster site to take digital pictures to document the damage done to infrastructure, vegetation, and roads. Emergency crews will also rely on calls from the public when trying to help track communities or objects needing to be removed from those roads. Engineers, such as the ones from the U.S. Army Corps of Engineers, also physically go out to each site of damage to conduct a volume assessment needed to estimate the cost of cleanup. If we have the ability to collect LiDAR data right after a disaster, we can help these efforts of response and cleanup assessment. But it isn't just the collection of data that needs to be fast. The analysis of these point clouds and imagery also need to be done quickly if it can be any help to crews on the ground. By automating the data analysis of post-storm data, time can be reduced in the face of emergencies and cost of repair planning. Compared to the cost of cleanup and the time it takes to assess debris volume using old methods, the cost of research and development of this type of technology are low. Like mentioned before, collecting LiDAR regularly as a base data set allows the changes caused by the disaster to be quickly identified by comparing the data before to the data taken right after the event. Although it's difficult to collect data right before an event happens, it is crucial that areas prone to these issues have a standardized set. This can have a large impact on how quickly emergency crews can respond. It also allows us to look back at the data and see which spots were hit the worst to better prepare for future disasters. Like mentioned before, one of the benefits of having LiDAR are the 3D models created from the elevation data. Having the 3D visualization can also provide a quick view of the ground and be used to visualize and better understand the terrain for those needing the information or those not in the GIS industry. Another impact of LiDAR point clouds is that it can be also classified into different categories, so crews can know what they're facing, like the washed out roads, damaged bridges, or debris. For example, one of the area of the post-Michael raster imagery shows that what looks like sand across the road, but it's difficult to tell if a truck can drive across it or if it's too tall like a sand dune and needs to be cleared. The elevation for this area can show how tall the sand is and whether it can cause issues or can be classified as normal road. Through the use of LiDAR in emergency situations, 3D models and LiDAR maps can significantly reduce times in response for disasters, and algorithms can also play a large part in delivering these products fast and efficiently. Using these 3D elevation models combined with vector data, such as street center lines and parcels, plus raster imagery, emergency crews have a comprehensive view of the impact left behind after the disaster. Many companies and researchers have looked into the effect that LiDAR has on these kinds of situations. One of the major studies I found was done by MIT Lincoln Laboratory, where they also collected post-LiDAR data sets and applied advanced algorithms to assess damages to help FEMA with emergency management. The first project was done in 2019, studying Hurricane Harvey and Hurricane Maria. The hurricanes were studied by estimating the volume of debris with the LiDAR data using a 3D Geiger mode set, and analyzed using an advanced processing algorithm to create a preliminary 3D point cloud while the data was still aboard the aircraft. This is extremely beneficial to cut down on processing time when the data needs to be out faster. Another study done by MIT was in 2020 with Hurricane Florence, where LiDAR was taken from 2018 and used with the same algorithm for road status and cleanup. They paired LiDAR with OpenStreetMaps in order to plan routes for emergency crews that could have been used in Hurricane Florence. The importance of this can help emergency managers make decisions regarding safe routes and see road damage at town or city scale. This AI that they used searched for these roads and flagged anomalies which indicate the roads as impassable. An example of this could be a drop in elevation could indicate a washed out area, or a cluster of points might be a tree across the road. Another study done with roads was also done by Kwan and Ransberger, studying LiDAR taken back when Hurricane Katrina hit. They used a buffer to show change detection in the roads to look for blockages and impassable roads, combined with vector data of the actual street lines. An elevation buffer was used to flag points that showed a rapid increase in 5 meters and a rapid decrease in 5 meters. The increase could show a large amount of debris, and the rapid decrease could show a hole in the road. Markers were then placed at these sites and exported into shapefiles to create a map for crews on the ground. The fourth project I looked at was Excellent Audit on Building Damage Assessment, which shows an algorithm for using LiDAR and a calculation of unsupervised building segmentation and damage estimation. This method used geometric features such as planetary and inclination angle, curvature, and size to calculate structural information. This assessment is an automatic way to identify building damage by using high-angled roof points to perform a classification based on the height. I think it's important that other analysis are done and what other researchers have found works for them, so that I can take from that and learn, so I can also proceed with my project. So based on the relationship between LiDAR and disasters that I researched, I determined that this is an area that needs more development and research gone into it. The goal of this project is to show a change detection analysis of the infrastructure using pre-disaster LiDAR from 2017 to post-Michael LiDAR from 2018 of Northern Florida. This project will show the importance of having the cost and research of improving widespread collection of LiDAR, plus the use of it during disaster recovery and response. LiDAR is preferable to raster imagery in these instances because it has the elevation component, plus the advantages I mentioned before, such as being able to collect points through foliage and any time of day or night. The elevation plus point classification can make a difference for agencies in charge of emergency management and cleanup, as well as insurance and government in charge of relief aid. It is important for agencies to understand the benefit of that having widespread LiDAR in preparation for disaster far outweighs the cost of research and development when compared with current methods of disaster response by plane or car. On this slide, you can see the part of the data that's already been processed. The top photo is from 2017 data where you can see the water tower is standing. And then in the raster imagery to the right, the water tower looks like it's fallen. And the LiDAR model on the bottom from 18 confirms that no part of it was left standing. And I think those models are really cool. There are several different data sets I'm using to accomplish this analysis. The first data set is the 2018 NOAA Emergency Response Raster imagery taken right after Hurricane Michael. I accessed it on the NOAA Digital Coast Data Access Viewer and used the tile index to choose an area that was most suitable in terms of the amount of destruction it showed. It is a geotiff format with a GSD from 15 centimeters to 30 centimeters based on the different flight paths. The projection was WGS 1984. The second data set is also from the NOAA Digital Coast Data Access Viewer and is the 2018 post-Michael LiDAR point cloud. Point spacing is 0.35 and the LAS files are tiled into 1 kilometer by 1 kilometer boxes. Projection was the North American vertical datum of 1988 and geoid 18 in meters. The last data set is my base LiDAR layer taken from 2017 pre-Michael. Point spacing is also 0.35 and 1 kilometer by 1 kilometer boxes. Projection was NAD 83, UTM zone 16 with geoid 12B in meters. Both LiDAR sets were all chosen to match the tile indexes that the raster imagery was chosen from, and all of these data sets are in northern Florida along the Panhandle. So the data needed some pre-processing before I could get started and to make sure it was the correct data I needed. When the data was downloaded, they did not all have the same coordinate system and reprojection, so reprojecting the data was necessary. The 2018 post-Michael data was also in version 1.2 of LP360 and needed to be updated to version 1.4. I loaded the LAS files into LP360 and used the LAS file analyst to scan and analyze each LiDAR set. For the 2018 post-Michael LiDAR, I used the export button to export it to version 1.4. Once the LiDAR was analyzed and exported, I created a new LP360 project to repair each layer and reproject both LiDAR sets into the coordinate system of NAD 83 and vertical system of geoid 18 in meters. The third and final LP360 project created had the correct LiDAR data ready for analysis. The raster imagery came in separate tiles due to the tile indexes I chose. So in ArcGIS, I created a raster mosaic to combine them into one image. The raster then was added to the LP360 project. The raster is used as the base layer with the 2 LiDAR on top as shown in the image here. This data selection is smaller than the full imagery so that I can do an analysis on the smaller amount. So this is the proposed workflow of the change analysis that will be done. At first, a small section of data will be taken to perform classification in both LP360 and ArcGIS to see the preferable method for the final product. Classification methods are available in both. The ground points are already classified in the downloaded LiDAR dataset, so that step can be skipped. All other points are unknown. It's important to remove random noise and low points from the point cloud so they do not get counted in the assessment or classified as groups they are not a part of. Noise and low points are common in LiDAR, so both LP360 and ArcGIS have tools to do this. Next would be to classify all the points into infrastructure, roads, and vegetation. While ArcGIS has classification of geoprocessing tools, it does not have a specific tool for roads and vegetation. This is where I'll see if LP360 can classify the roads and vegetation with more accuracy than ArcGIS or vice versa. Manual classification is also available, but that is to hopefully be avoided to prove the efficiency of these algorithms. Part of the project is to be able to identify damaged buildings, so it is important to separate them from the other points. Classification will be completed and DEMs will be generated from the classified point clouds into the LAS dataset to raster tool in ArcGIS. This is the next section of the proposed methodology. The building assessment is the most important part of the analysis that will primarily be done in ArcGIS. For each layer, building footprints will be extracted. The geoprocessing tool called LAS Buildings will be used to create 3D buildings using a multi-path layer. With building footprint vector data and LiDAR point clouds, a large 3D city model can be built from each set of 2017 and 2018 to see the differences. An NDSM will be created from each set so that elevation differences between pre-damage in 2017 and post-damage in 2018 can be flagged. This part will be able to show the change in elevation between the 2 years so that building damages can be shown. This is another part to see if ArcGIS or LP360 is the best option to flag points. In LP360, a basic filter that sets synthetic points will be used to move the flagged elevation differences in class 22, which will be labeled as destruction points. A manual classification is available in ArcGIS. The next part is a statistical analysis to find the amount of destruction in volumetric terms. The amount of volume for infrastructure cleanup can be presented to engineers and insurance for relief aid estimation. A large 3D model of the entire area can be shown in ArcGIS, while LP360 can use the profile and 3D windows to show certain areas that were flagged in the change detection for a close-up examination. This is the project timeline that will take place during the months between 596A and 596B. So today is my proposal, and I'll hear that feedback from the peers and advisors. Starting in January, I'll test my workflow all the way through with a small amount of data to make sure it's acceptable and change things as needed. This is necessary to find the most efficient and time-effective way to process the data. The end of January will be the start of the final workflow with all the changes made, and I'll be able to work on it through February. By the week of February 26th, all of my methodology sections should be finished and completed. This means the analysis has produced results and figures that are acceptable to present in the final capstone. I'll be able to start on the final paper by March using notes and research I've done throughout the analysis. The final paper with all sections should be finished the week of April 2nd, with the final presentation portion started on April 9th. The presentation will be made using the paper as a guide. By mid-April, everything should be done with both the paper and presentation so that speaking notes can be started and practiced in May. In early June, I'll present at the ASPRS virtual conference, whose date is yet to be determined, or if anybody has any suggestions for conferences as well. This research done on LiDAR is important to many companies and stakeholders. First, the most important people that will benefit are emergency management crews that are the first responders in a disaster situation. This includes EMS on the ground, engineers such as the U.S. Army Corps of Engineers, Federal Emergency Management Agency, or FEMA, and Humanitarian Assistance and Disaster Relief, or HADAR. Having this kind of LiDAR data in real time can help teams do their jobs quicker and more efficiently as they assess damage, rescue, and cleanup. Government agencies also benefit from the cleanup efforts because they are where the relief aid comes from for these crews. This includes insurance companies and engineers that need an estimated cost of building damage to present to their clients. Gas and electric companies also need fast and quality data to get power back to residents. The general public can also benefit not only needing to be saved from blockage or damaged houses, but also afterwards in cleanup efforts and home rebuilding. Each of these people can benefit from public data maps created where from LiDAR, where they can pull information they need to do their jobs. LiDAR is a newer technology that can help the future of science. As mentioned before, LiDAR can be shown in day or night, which allows LiDAR to be collected anytime right after the disaster has calmed down. While engineers can provide debris volume calculations, the future of volume calculations can be produced quicker and easier using automated algorithms instead of waiting for manual classification. The importance of collecting LiDAR of an area is preparation of a disaster is immense, as it can help agencies get ready for the future. Another change that can make on the future of science is allowing researchers data to compare from before and after that can show changes in specific storms over time or specific areas that are affected the most. This can also help stakeholders such as the government be prepared in the future to be able to help the public in the face of a disaster. A great quote by Halal Khan, leader of the Active Optical Systems Group, said, "Data is great, but what people really want are specific questions, are answers to specific questions. Where can I drive? Where can I position relief supplies? Where can I pitch tents? Where are there downed power lines? Where can I land a helicopter?" The preparation of this LiDAR can help science and the general public. For myself, this research can help me because I like studying about disasters and the effects of damage done on the infrastructure around it. Studying more about this can help me get into the emergency management industry so that I can also help in the future with these types of situations. I want to do research and develop ways to minimize the effects of damage that can be caused by natural or man-made disasters. So there are a few products and results I'm hoping to achieve that are listed here. So first are the classification maps from the LiDAR data from 2017 to 2018. The next will be a map of flag destruction points showing the buildings damaged by Hurricane Michael. This also will include the point statistics included in the change detection, as well as a volumetric assessment of the amount of damage caused. The final images will be a 3D model map from ArcGIS showing a citywide 3D model, as well as close-ups of certain damaged areas from LP360. I think that LiDAR is such an important discovery and remote sensing instrument that can be used to impact the world of emergency management. And the background section showed how current methods are and how LiDAR can improve response time as well as cost of disaster cleanup. Other projects have already been done on this subject, with many that will continue to surface as more disasters happen in the future and LiDAR development continues. While Hurricane Michael is not the hardest hit disaster in terms of damage, it was available to the public, which needs to happen with all disaster LiDAR data so that companies can access it to help with cleanup and damage assessments. For future work, it's incredibly important that more research and development is done on LiDAR to make a bigger impact on GIS in the public world. And that is my presentation. Thank you for listening, and I can take any questions you might have.
All right, thank you, Brooke. Questions for Brooke?
In the chat, Brian said, "Great presentation, thanks. Do you need to use a high-powered computer with lots of RAM and CPU to work with the LiDAR data, or is a normal desktop laptop able to handle it?" I have a pretty high-powered computer. It's like one of the newer ones. I bought it in 2021, so it's got lots of RAM. I would say that it's probably harder. I don't know how well the programs would run if it was using a bunch of LiDAR, because mine already takes a little bit of time. But I think if I had even like a bigger computer, it would run even faster. So I think it would just slow down the data analysis. So it's better to have a better computer, I would say. Yeah, it definitely, it took a while to download. So if the future of LiDAR work, I think, would be done by obviously bigger companies instead of individuals that would have like these bigger computers that could handle the analysis well. Amy says, how might flooding impact the damage assessment derived from the LiDAR data? So LiDAR, when it shows water as no points, so water can't reflect LiDAR back. So it would just be blackness. So it actually helps kind of because you can tell where the water is because there are no points there. So I think it would be beneficial to see like how flooding is. Hurricane Michael didn't flood very much. It was more the wind that broke the houses and everything. So, but I think LiDAR is definitely helpful in floods because it'll just show as black and you can definitely tell where the water is.
I've got a bit of a comment.
Yeah.
This is Brian. I was in Houston for Harvey. One of the big questions that we had at the time and still are whether or not the Addicks and George Bush reservoirs were going to hold. They're retained by earthen dams and they took heavy damage and they haven't been maintained over the years that they've been built. One of the big problems we came up with as far as getting data was the Army Corps of Engineers at the time was actively trying to limit liability. So data wasn't publicly available. It still isn't as far as the structural durability of those dams.
Yeah, like the volumetric computation stuff. Yeah.
So I'm really interested if a private, not publicly funded, but a privately funded LiDAR survey of these dams over time would greatly help the areas that are downstream from those reservoirs.
Yeah, I definitely think so. Because I think part of my project is I want to show that, it's helpful to have LiDAR collected, even though not even just right after the disaster, but have like a standardized set of these areas that are prone to it. Because yeah, like you said, obviously that data is not available to the public. And so it is hard to do like an assessment on that because they could have the data, but they're just not sharing it. And so I think it's better, for the government and for other entities in the long run to be able to share that LiDAR data because they're going to spend more in disaster cleanup than they are if we can fix the problem. Like you said, like those dams need to be fixed and they're just going to keep creating more damage if they're not fixed. So that would be a really cool analysis if someone could get that data. I think that would be really cool and helpful.
Very helpful, yeah. Thanks.
Yeah, thanks for the question. Anybody else?
So this is Jim. With this disaster occurring about 4 years ago, am I right in understanding that this is really mainly a proof of concept for future disasters, or is there still some benefit that could be had for the area that was affected?
It is more just like a proof of the concept, just because, yeah, most of the disaster areas have already been cleaned up, except I guess the dams. But yeah, there's not a ton of LiDAR data available to the public regarding disasters. So I think it's, yeah, more of a proof that we do need it as soon as like disasters happen. So I think it would be really beneficial.
Yeah, good. I could certainly see your project hopefully making that point.
Sweet.
No
Yeah.
pun intended. Any last questions for Brooke? All right, well, thank you. Nice job. Good luck on your project and finding a good venue for it.
Thank you.
All right, well, that is going to bring us to our third presenter, who is going to be also doing something on change detection, Catherine Wang. Catherine, are you ready?
Yes, I am. Can you see my screen?
I can, and I can hear you just fine.
Okay, perfect. Thanks, James. Hello, everyone. My name is Catherine. My advisor is Professor Patrick Kennelly. Thank you, everyone, for being here today. I actually just got COVID, so please excuse my slightly weaker voice. My capstone project is analyzing volume loss of alpine glaciers in Glacier National Park from 1850 to 2020. So why am I interested in glaciers? Glaciers are the largest freshwater reservoirs on Earth. They have a critical impact on the planet's entire ecosystem. There are two main types of glaciers, continental glaciers and alpine glaciers. Continental glaciers cover vast areas of land, and they're only present in Antarctica and Greenland nowadays. Alpine glaciers form on the crests and the slopes of high mountains. In the past few decades, alpine glaciers are disappearing at an alarming rate as high altitudes react profoundly to temperature and precipitation changes. Glacier retreat is recognized to be one of the most observable and direct indicators of climate change. The area I'm interested in is Glacier National Park. It's a scenic national park in the Northern Rocky Mountains in Montana, adjacent to Canada's Waterton Lakes National Park. I first visited there in the summer of 2010. It's about 3 hours drive from where I lived. And as its name implies, it's famous for its glaciers. You can find alpine meadows, carved valleys, and spectacular lakes there. The park encompasses more than 1 million acres and welcomed approximately 3 million visitors last year. I've lived in Calgary, Alberta, Canada for over 10 years, and we're close to the Canadian Rockies. I always felt deeply connected to the alpine glaciers, especially knowing that they're disappearing inevitably. And I can really see it firsthand, like how much they have shrunk in just a few short years. The period between 1550 to 1850 is known as the Little Ice Age. In this era, the temperature in North America was cooler compared to the previous and subsequent periods. So many glaciers were formed and expanded during these centuries. In 1850, Glacier National Park was home to over 150 recorded active glaciers. Active means that they exceed 25 acres in area, and glaciers less than 25 acres are considered inactive. Of those, only 26 active glacier remains as of today. And that is approximately a whopping 83% loss in total ice mass since the end of the Little Ice Age. And here's a direct comparison of Jackson Glacier from 1912 and 2009. As you can see, the majority of it in this view in 1912 is gone now, and the change is very drastic. Consequences of rapid alpine glacier retreat include sea level rise, critical impact on the hydrological cycle, landscape alteration and hazards, as well as cultural and spiritual effects on the nearby communities. There are compound factors that affect the rate and magnitude of glacier retreat. The climatic factors include temperature, precipitation, radiation, humidity, and wind. And the size, type, elevation, and debris cover of each glacier vary. So these have an impact on their melting pattern as well. Out of these, temperature and precipitation data are the most available to conduct a correlation analysis. In the past, systematic studies of the remaining glaciers in the park were conducted by various groups since the 1980s. In 1988, Carrara and McGimsey compiled data from various sources such as historic topographic maps and air photos to produce a map showing the distribution of moraines and the extent of glaciers from the mid-19th century to 1979 in the Mount Jackson area. The map illustrates the outlines of glaciers in the area over numerous years. This image here is a small portion of the map. A table summarizes and compares the area and terminus elevation of each glacier during the mid-19th century and 1979. In 2003, a group modeled the climate-induced glacier change in Glacier National Park for 1850 to 2100. They digitized glacier extents from the previous study that I showed on the last slide for several intervals between 1850 and 1979 and predicted post-1979 glacier retreat with a simulation model. Predictions are based on an empirical analysis of the previous decades and of the spatial distribution of melting. Predictions are made for two possible climate scenarios. Number one is the linear temperature extrapolation scenario. And number two is the carbon dioxide doubling scenario. For the linear temperature extrapolation scenario, there will be a 40% decrease in glacier area by 2100. And for the carbon dioxide doubling scenario, the glaciers in this area will disappear completely by 2030. More recently, in 2017, a group from USGS conducted a study documenting the retreat of 37 active named glaciers in Glacier National Park between 1966 and 2015. The study summarizes the area change of each glacier over half a century. Of the 37 active glaciers, again, which means they have an area larger than 25 acres. 11 of those here on the first table are no longer active in 2015. Some of the glaciers on the list lost as much as over 80% in area. So the objectives for this project would be for the period from 1850 to 2020, I will derive glacier extents and elevation from historic data. I will calculate area and volume change over the years. I will identify correlations between glacier change and climate factors. I will estimate glacier extents for the in-between years where there are no data, so to have a continuous display. And I will develop an interactive web map to display the result. Compared with the previous studies I mentioned, my project will focus on a volume calculation in 3D instead of area calculation in 2D. The previous studies have often compared changes in glacier area over time, when volume is a more significant indicator of the change. And I also plan to focus more on the visualization of the results to provide a more effective visual impact to raise awareness of this issue rather than the traditional research of in the past that focused more on the quantitative results. My final deliverable will be an interactive web map with the time slider that visualizes the change of glaciers over time. I have compiled some data for the study. I will heavily rely on historic topographic maps to build my database. There are topographic maps available from USGS from the year 1904 to 2020. And there are also glacier margins that were digitized from the previous studies that's dated back, all the way back to 1850. And to fill in the gaps, there are also some additional aerial imageries available. And I also got the digital elevation model from 2021 with a third of the arc-second resolution. That's approximately 10 meters resolution for this area. From the historic topographic maps, the glacier outlines and contour lines will be digitized separately. The outlines of glaciers can be used to compare area change over time, and it will be configured and added to the final deliverable. And that together with the digitized contour lines, they will be applied to create digital surface models. And with the digital surface models created for the selected years, volume change for each interval can be calculated by tools such as raster calculator. I will look for patterns and correlations from the volume calculation results. I will estimate glacier extents for the years in between where there are no data available. This is an optional part. It's a predictive spatial model to derive glacier extents for the future years. It's unlikely to fit within the scope of this project, but it's something I hope to do after. And all the results will be configured to fit onto the final deliverable. So here are my anticipated results. I will have a database of glacier profiles for every year from 1850 to 2020. I will have a dashboard to examine the contrast in glacier area and volume over time, an interactive web map to visualize changes of glacier extents and volume over time, and identify associations between climate change and the glacier retreat. I do have some concerns and limitations for this project. Since I'll be using data going back as far as 1850, I can't expect the data to be as accurate as it is from 2020. And I'll also be using data from various sources in different formats. Therefore, I will perform a systematic error analysis. One way of doing it is by randomly picking points from contour lines on the historic maps and comparing them with the current DEM data. There is expected to be a delay response of glaciers, especially for the larger ones, to climate change. So the correlation analysis might be more complex than I anticipated. Here's my anticipated timeline. I'm planning to take 596B in the fall 1 or fall 2 term next year. From the beginning of the year, I will start preparing and digitizing the data. Then I'll do my analysis in the spring, and I expect to start developing my final deliverable map and dashboard in July and August. And then finally present my project in October or November next year. My top choice for my presentation is at the NASA's annual meeting. It's announced that it will take place in Pittsburgh next October, and there are some other options as well. And that's the end of my presentation. Thanks so much for listening.
Thank you, Catherine. Very nice. Beautiful set of slides, by the way.
Thank you.
Questions for Catherine? Looks like you have a comment from Brian about
Yeah.
Other data that you might want to look at.
Have you decided on what variables I will include in my correlation analysis? For now, I would only do it for temperature and precipitation since it's the most accessible data. Other factors such as the terrain and elevation will be more complex, and I will also consider to do that as well.
I had a
Anyone
question
else? Yep.
About the digitization of the glacier margins and the contour lines. I could certainly imagine tracing the glacier margins, but the contour lines, I'm guessing that you must have some sort of automated process in mind to capture those, or were you going to do that?
I was planning to do it manually,
Okay.
but I will certainly look into an automatic way of doing it if
Yeah, I don't know
going
to
to
what
make
extent,
it much easier.
I don't know to what extent that's possible. I'm just, I assume then that you're going to be doing selected contour lines and not all of the ones that we were seeing on the examples there.
Yeah, I will just do it over the glacier, so I'll have a 3D profile for each glacier over the years.
Okay. Okay.
Any more questions?
Yeah, I agree. I think this is, if you're able to deliver on what you proposed here, it's going to be a really cool product that lots of folks would be able to get a lot out of.
Yeah, thank you, David. Thank you, Brooke.
All right. Well, thank you, Catherine.
Yeah, I'll leave my email in the chat as well if anyone has any question.
All right. Thank you, Catherine.
Thank you.
That'll bring us to our final presenter for today, Benjamin Brower. Benjamin, are you ready?
I'm ready. Just, the joys of public speaking. But I am ready when everyone else is. Let me get my screen share up. All right, can everyone see?
It's still coming in for me. There we go.
All right. So hello, everyone. My name is Benjamin Brower. I am a GIS specialist in Ocean County, New Jersey. And my capstone proposal is a wildland urban interface of the Pinelands National Reserve. And I had the joy of working with Dr. Erica Smithwick throughout 96A as my advisor. Oh. So the overall presentation, we've heard a few of these already, but we're going to go through the background of why I'm interested and want to do this for my capstone project, the goals and objectives of it, the methodology of how I'm going to acquire my data, analyze and process it, a perspective timeline. I think for me, or since I have 596B in the summer semester, I'm going to have a bit of a gap. And then also in terms of a presentation, it might be something I want to do, but it's right now I'm more class focused just because of like a work-life balance. It's a little bit heavy now with the work. And then along with my anticipated results of this project and leave some time for available questions. So background of it, I actually grew up in the Pine Barrens. I'm from Bass River Township, New Jersey. It is home to the oldest state forest in New Jersey, Bass River State Forest. Both photographs that you have seen in this presentation are ones I've taken. This is a white pine plantation that was planted in the forest back in the 1930s by the Civilian Conservation Corps. And a little bit of information, the Pine Barrens or Pine Lands, the term gets thrown around a lot. The Pine Barrens is the colloquial from when the colonial settlers came in the 1700s, and they claimed the land was barren because of the sandy soil and they could not grow any crops. But the Pine Lands has become more of the real term for this area. It's located in southern New Jersey, and actually between Boston and Richmond in the northeastern United States, it is the largest open space between those two metropolises. And it wasn't always going to be that way. Actually, in the 1960s, before the National Reserve was created, there were plans to create a jet port that would have supported the New York metropolitan area. But then conservation efforts, and most famously a book by John McPhee about the Pine Barrens, helped conservation efforts, which led in 1979 to the creation of the first National Reserve in the country. And with that, it's actually, this area is under the jurisdiction of the Pinelands Commission. It's a 12-member group, and it is made from local, state, and federal authorities, and they help manage the land of the area. And then for a wildland urban interface, or as I'll be saying throughout the presentation, a WUI, this is a means of assessing the interaction between development of humans and wildlife and wildland in particular. So over here, I have this is the interactive map of the Pinelands National Reserve from the Pinelands Commission website. This is a screenshot. I do have a link in my presentation. So it shows that unlike a national park or other areas of preservation, a national reserve has multiple entities that are controlling the land, but it's also going to be slated for different uses depending on the interests, especially because there are several towns within the Pinelands. They don't want to have it where there can be no development at all, but they still want to conserve some areas. And that's going to be an interesting aspect of doing a wildland urban interface in this area. So my overall goals and objectives, it mainly stemmed from, actually, I was at the Esri User Conference this summer and seeing different interactions or different data interpretations throughout the country. And one that got me in particular was fire evacuation routes around the country in relation to the volatility of fires. So with the Pine Barrens, it is equal or near equal to further out west, such as California, in terms of wildfire volatility. But when I looked at to see how our evacuation routes were mapped in Ocean County, New Jersey, there was no data. So that's where I originally got the inspiration to work this more towards my capstone of having available data of just having people more informed of wildfire risk in such a volatile area. So with that, I have two questions that I want to answer throughout my capstone. How has the WUI changed in the Pinelands National Reserve, mainly since its creation in 1979? So with that, I would like to do for each decade of the existence of the Pinelands to create a wildland urban interface map from the best available imagery data and how it correlates with the land cover data in order to calculate the WUIs. And then along with that, I would also like to calculate differences between the wildland urban interfaces between the decades to see if there's significant growth, possible decline, or even if there's minimal growth. And then what factors are going to be responsible for the changes of this interface. I would just like to analyze more of just the land cover analysis to see what's playing, like is development increasing, is there less vegetation, and other factors that could change the interface. So for methodology, I think major phase is going to be acquisition of data. Over such a long period of time, there will be multiple different Landsat usages, mainly Landsats 3, 5, 7, and 8. From the state of New Jersey, there's going to be municipal boundaries to help establish my study areas, Pinelands land management areas to help not only corroborate with the land cover analysis, but also be set as predictor zones for potential wildland urban interfaces, especially with my major areas of study, which will be Bass River Township and Manchester Township in New Jersey. Census data will be acquired, but mainly around the county level, just to get the township populations of each decade, more to help with corroborating. And definitely the National Land Cover Database from 2019 and 2006 to help build out my template for land cover analysis. Excuse me on that. And with the areas of study, as stated before, I'm going to use Bass River Township in Burlington County, New Jersey, and Manchester Township in Ocean County, New Jersey. They're shown highlighted in this map to the right. I like these similarities both in size, the different land uses within each township in regards to Pinelands land management, and the major difference being that Bass River has not seen significant growth since the creation of the Pine Barrens. As of 2020, their population was around 1,225 people, whereas Manchester, since the creation of the Pinelands National Reserve, has seen an increase to around 45,115 citizens. So having that display that even though there is population growth within the area, it's not going to be uniform, and throughout the townships within the Pinelands, there's going to be different areas of focus of how the urban wildland urban interface is increasing. So for a definition of a WUI, we'll be following similar to the US Federal Register for its definition. That is a building density over 6.17 units per square kilometer. That also includes that at least 50% of land cover is wildland vegetation. That would make it be an intermix between urban and wildland, or it can also be an interface where there'll be under 50% wildland vegetation near the building, but it's within 2.4 kilometers of a patch of wildland vegetation, at least 5 square kilometers in area, with 75% of it being vegetation. And to help build out that building density, the minimum number of structures will be 1 structure within a 100-meter radius. And this is from a research paper that I heavily cited by Amanda Carlson and her associates. And she went with the hypothesis instead of using census data, which has been the traditional means of assessing where buildings are and building the WUI from census data, actually through a land cover analysis and finding where actual buildings are located, it can be as accurate or even more accurate to build out a wildland urban interface. And this would help build out such as a non-WUI where there's not much wildland vegetation, and then an intermix where buildings are within wildland vegetation, and then an interface where there's development, but it's close by to wildland vegetation. As previously stated, my project timeline is going to be a bit longer, so I don't have definitive dates as of yet, but the major phases I foresee will be a data acquisition and analysis. The data acquisition is mainly going to be gathering Landsat imagery, finding where there's little cloud cover, probably during a growth season, but also to help find buildings maybe within the same year of finding winter imagery where there's less vegetation and finding out the buildings. Oh, excuse me. And then there will be census data to help with the decade population and just helping corroborate with the analysis, National Land Cover Database, and then from the New Jersey Office of GIS, the data for Pinelands land management, municipalities, and municipal zoning data for Manchester and Bass River Township. And then having all that data being pre-processed to within the areas of study in the two towns. And then for analysis, performing a land cover analysis within those areas of study, calculating the wildland urban interface from the land cover analysis, and then from that analysis, calculating the statistical change between if an area is an interface or becomes intermixed or becomes non-WUI throughout the different decades, and creating maps for each decade of its interface, and then having comparisons from each decade. So within that, my anticipated results, along with all those maps created of the interface and the calculated differences, I'm foreseeing that the WUI will have increase in the Pinelands National Reserve, but mainly in the areas that were selected for development by the Pinelands Commission for land management. The preserved areas, I think, will remain fairly constant in terms of being a non-WUI or more of an interface if there's development nearby. I also foresee that Manchester Township will show more significant change over time than Bass River Township, mainly because of population. Along with that, I think the main factor is going to be a population increase within the Pinelands area that is going to cause the changes and leading to further development. And again, showing that by having the two towns where population growth has been minimum and one where it's been significant. And that's it for my presentation. Sometimes I just speak a little fast, but other than that, if there's any questions, please feel free to ask. And that's it. Thank you very much for your time.
All right, thank you, Ben. Looks like you have a suggestion from Brian in the chat.
All right, you could potentially use NASA's DNPA 46A2 black marble data for structured population detection versus green space. Thank you very much. I'm going to make sure to get that bookmarked. Thank you very much for that.
Questions for Ben? So aside from this being a place that you grew up in and still live in, I believe, your motivation for this has a lot to do with wildfire concerns. Am I understanding that correctly?
It has come about through wildfire concerns because of the volatility of wildfires within the Pinelands National Reserve. There actually was a recent fire this summer where in Wharton State Forest in the southern part of the Pine Barrens, where over 12,000 acres was burned over a few days. So it is something where I think just because since the 1930s, this New Jersey Department of Forest Management has had concerted efforts of wildfire risk assessment and also doing prescribed burning since the 1930s in the area where we haven't seen many fires outside of the reserve doing home damage.
Good, thank you. Other questions? Looks like you've got one from Fritz.
Good job. I may have missed this in your presentation, but have you considered investigating factors that have been used in the West to relate to your present research? I do want to consider it. I think the major things, especially in relation to the Pinelands versus out West, is the Pinelands is a relatively flat area, whereas out West, especially like elevation plays such a different role, and a lot more federal land is out there as opposed in New Jersey where most of it is state land. But I do want to consider that and maybe look into further research of out West with efforts, especially in regards to interfaces and land management. Okay, I was thinking about the management differences. I think with the Pinelands, it's very unique, especially in New Jersey, given that it's in between Philadelphia and New York, that the largest open space is actually enforced by a government institution to stay the largest open space in that area. So it is a very unique aspect where maybe further out west, it's just federally mandated that there's open land. Thank you. Are there any other questions? Oh, yeah, I'm curious about this too. Oh, this is from Brian. Are the pines that the CCV planted native to this area? I understood that some pines needed fire for reproduction. Quite a few actually, and the ones I showed, the white pines, were not native to the pine lands. And actually, those pictures are from a previous project where the Department of Environmental Protection wanted to cut them down because of fire tower obstruction. And then other than that, there are some areas where the native species have been there the whole time. One area, it's called the pygmy pines, where they're very short. And what main reason they are short is because of they mainly reproduce with through fire, like burning the area, and they don't grow that high. Okay.
And you had a map up showing like land cover of the area, and there were some red areas that were labeled, I believe, Pinelands Village.
Yes.
I was curious to know what those areas were.
So those are towns that were already established when the Pinelands Commission went to set about the National Reserve. So it is something, I think I tried to explain, like usually like with the national park, like it's all preserved, it's all intact. But with the reserve, it's more, all right, we have this area for preservation area, but we still have this area for development. So within the red area, that's where like a town will be. So for example, like where I grew up, I think that's a Pinelands Village and it's called New Gretna.
Okay.
And that's just, but there are different land classifications that within my final presentation and project that I will go further into detail.
Okay, thank you. Any other questions for Ben? All right, well, as always, this was a great set of engaging talks across an interesting range of topics. Just a reminder, please fill out the peer review form for today's presenters. I posted the link again just a moment ago. But other than that, thank you all for attending. And I want to wish the best of luck to all of the 596A students on completing your work and finishing your degrees. Thanks, folks.
Thank you.